Function translations, the second unit of integrated 3. A reminder how this works. We start easy on a basic video game analogy world, and then you move up different levels until you get to the big boss at the end of the fight, metaphorically. Last time that fight was with a little bit of proofs, diving in to look at different types of angles, how to fill in blanks with proving that two triangles are similar, talking about congruent and similar triangles. Now we're going to enter the world of functions. Specifically, we're going to enter the world of quadratic functions. And this will end up working our way up to a boss fight of quadratic formula, completing the square. So if you hit attempt quiz now, again, yours says attempt quiz now, mine says preview, you'll see some notes for the start. And you'll also notice that this Desmos calculator is up per usual. If you have not already, please take a moment and open up a new window, not tab, but window, so you can have these side by side and compare them throughout the assignment. We're going to be dealing with quadratic functions, and what they are, little southern accent, what they are, have to do with y equals x squared. So check it out. Anytime that I have a function with a y equals x squared as what's called the leading term. So I could still have some x's in there, I could still have some numbers in there. You're still going to end up with this general U-shaped parabola. If I was to add something larger than a 2 in front of the x, though, like say an x to the third power in front, well, now look at the shape of this thing. It has lost its entire structural quadratic function integrity. Whew, say that 10 times fast. So we're not going to deal with that. Instead, we're going to just be having these U-shaped graphs all the way down, and starting with the simplest one, which is just y equals x squared. You can see that this is a regular parabola, a nice U shape. That's bottom or minimum is at this point right here, and you can always click on that, at 0, 0. And the question is, what happens to this graph, very simply, if we do the following things to it? If we plus 2, if we minus 2, if we use parentheses and plus or minus 2 on the inside. So let's see. Well, I have it at 0, 0. I know that. If I was to add 2 to the outside, now 0, 2, I see that from the point 0, 0, it moves up 2. So find the one that's plus 2. It could be in any order. Don't just copy, but find it could be the first one, the second one, third one, and say that it's shifted up. Well, let's return that to 0, 0, and see what happens if we go minus 2. Well, plus 2 went up, so minus 2 should go down. Yep, now it's 0, negative 2. That minimum went down 2 spots, so this went down. Then, well, we only have 2 options left and right. You would think, though, this is a little counterintuitive, that if I had an x minus 2, well, left and right, I start at 0, 0, negative 2, right there. It's going to go left, correct? Notice how I didn't say left, right. That's one of my most frustrating English things. You're like driving and you're saying, all right, do I go left or right? And then no one says anything and you say, okay, I go left, right? Really, you mean left, correct, but, English. Okay, so here's the thing. The parentheses, anytime you see parentheses, just be in the habit, especially this unit, of thinking opposite. So normally minus 2 you would think left, but because it's in parentheses, check it out, and if you forget how to do the squared, our squared button is here. You can also hit Shift 6 and a 2. It ends up being moved to the right. So if you see parentheses, always think opposite. The minus means right, which means the plus, yep, it means left. And these are going to serve as our helpful notes, not just for this lesson, but for many lessons this entire unit. Okay. Plusing without parentheses, up. Minusing without parentheses, down. Minusing in parentheses, right. Plusing in parentheses, left. Now we're just going to go over a review of each of these concepts right off the bat. So minusing a function on the outside, this is what this means. It says describe the direction and the amount of the translation that occurs to the function f of x. F of x means a function in terms of x. We did this in integrated 2, talking about inputs and outputs. You enter something in a machine, you get out hopefully the same exact thing. If not, it's not a function. Well, notice this minus 8 is not in parentheses. It's out of parentheses. And if we ever forget what that means, I can hit shift 6 and a 2 again for that. Notice how it went down 8. That's because the negative is not inside parentheses. It's not left and right. It's up and down, and in this case, down. Similarly, if I have my function and I add 10 on the outside, not being in parentheses again, it moves up by the amount of units that we have. If I'm going too fast again, hit pause. And then we'll catch up together on number 4. Plussing inside parentheses, if you forgot what that was. Notice too that the squared always goes on the outside of the parentheses. This really screws up people. If you put x squared on the inside, you're going to get it wrong. All right, so plussing on the inside of parentheses means left. And that means, again, for the last one, minusing in parentheses means right. And again, it's right by 7, not by negative 7. We're always going to talk about this distance here as a positive number. Okay, pretty straightforward. 5 out of 9. We don't have 10, we just have 9 problems today. Then we talk about wanting to match the graph. Okay. So notice, first of all, that this function here is not a perfect parabola. This is like an absolute value graph. It's in the shape of a V. And it wants us to figure out what to do with a blue graph given some equation. I've got f of x plus 7. You'll notice that the red graph is always in the middle. It's always at 0, 0. It never changes. What changes is the blue one. And so we have to figure out where is our blue graph going to be if we have plussing 7 in the inside of parentheses. Well, conveniently, I've already left up on my Desmos calculator the plussing in the inside of parentheses example. And a reminder, that means it's moving left. And notice, not just left, it's going to stay on your x-axis. So we want to find a blue one that's also on the left and also on the x-axis. So I can see this is writing down. Oh, look at this one. The blue one is to the left. It's still on the x-axis. It's at negative 7. Perfect. The other one's to the right. Down and left. Just down. Just up. Nope. We want the one that's just left on the axis. And blue goes the dynamite. See what I did there? Stupendous! All right. Plussing 7 on the outside of parentheses. What is that? Are you screaming it out there? Up! It means up. Yes, you're right. Voice from across town. It means up. And notice it's again just on the axis. In this case, the y-axis. So let's find the one that's up on the y-axis. That's right. That's left. That's down and left. That's up and left. That's just up. What up with that? What up with that right there? Hey. Boom. Got it. And the last two, little challenging problems at the end of the assignment. We're going to write an equation for the transformation. Translate the graph y equals x to the 5th down 2 units. All right. Well, look at what x to the 5th looks like. It is, again, one of those kind of weird ones like we had x to the 3rd. In general, when you have an odd number, it'll always look like that. Kind of crazy. That contrasts your even numbers, which are just fatter versions of parabolas. Okay, so we have x to the 5th, and we want to move it down 2 units. Well, we know that down and up mean no parentheses, and down simply just means minus 2. So for you, here's what you're going to do. You're going to type y equals, and then you're going to type what you have for your x, like mine is x to the 5th. So I need to type x to the 5th. Here's how I do to the 5th. Hit shift 6 Shift 6 gives a little arrow that means to the power of, then 5. And simply, what do I do after that? I just hit -2. You can separately hit this little button with the square root and open up all these symbols, and then you could do the 5th power that way, but I'm recommending just don't do that. Just hit Shift 6 and then a 5 or whatever you have that matches your exponent. Like for me, on the next one, I've got to the 3rd power, so that's what I would do. But notice I'm going to the right now. Now this is the one that you really have to watch out for. So pay attention. If you've been sort of zoning out this whole time, lock in here, because this is what everyone always screws up on, even when they know, oh, it's to the right. That means I have to do -9. The problem is that people want to put the to the 3rd power on the inside. It's what we just did. It's what goes with the x. Don't. Don't. Instead, remember that it has to go on the outside of parentheses. So I'm going to put to the 3rd. Oh, no. Control Z, by the way, is your best friend if you didn't know that. Control Z or Command Z on a Mac, it brings back whatever you just erased. That's what I used for that. Clever. The to the 3rd power goes on the outside. If you put it on the inside, you're going to get it wrong, and you're going to be like, what? Mine looks the same. No, not on the inside, the outside. And notice, too, that this is one of those confusing ones, that the feedback, for some reason, they didn't do this on the last one, they give it to you in expanded form, which means people miss it, and then they go to check their answer, and they go, what the heck? So I'm so glad I have this video recorded now that I can tell you out there, virtually, ignore the confusing expanded form, and just make sure you put the to the power on the outside, not the inside. Okay. We are perfect. 9 for 9. Submit all and finish. And boom goes the dynamite. There it is. As always, I hope this video finds you safe, happy, healthy, well, that you're having a good day. Life's progressing well for you. Best wishes on your week. Take care. And yeah, just have a great everything from Dylan.